Hey, it's Mr. Estrada here, and in this video I'm going to show you how we could use the Pythagorean theorem in a problem involving a chord and a perpendicular bisector. Here are the guidelines that I'm going to be going through as I solve my two problems in this video. So here is the first example. It says find the value of x to the nearest tenth. So we have a chord here, and it measures 8, and then we got another we got a radius here which is x, and we got a perpendicular bisector which is measuring 3, and that perpendicular bisector is of course perpendicular to the chord, and it's also cutting it into 2 equal parts. So I know that this part is equal to this part, right? I know that from here to here and from that midpoint to here, those two segments are equal. All right, so let me go back to my guidelines. The first one says, remember the bisector will split the chord into 2 equal parts, and that's what we just saw here. Therefore, we could say, since the whole chord is 8, this will be 4 from here to here, and from here to here, it will also be 4, right? Because it's a perpendicular bisector. It's cutting the chord into 2 equal parts. The second guideline says draw another radius. So I'm going to draw a radius from here to here. And you'll see why. I do that in a second. Let me just move that 4 out of the way. I'll put it here. So this radius here is of course equal to this radius here, right? All the radii are equal to each other, so I could label this x. Now you can see why I drew that other radius, because if I could find what x is over here, I will in turn find the value of x, which is what I'm being asked to do. The third guideline says highlight the right triangle. So hopefully you could see right now that this, of course, is a right triangle. And we can now use Pythagorean theorem to solve for x. So the Pythagorean theorem says a squared plus b squared equals c squared. So we got 4 squared plus 3 squared equals x squared. Remember, in the Pythagorean theorem, x is always the hypotenuse. So you're going to do some Pythagorean theorem. You'll see, of course, that x is equal to 5. So the answer is 5. There was no need to round here. So that's our first example. And let us now go to example 2. In the diagram below, circle O, radius OC is 5 centimeters, chord AB is 8 centimeters, and is perpendicular to OC at point P. What is the length of OP in centimeters? Let's begin by labeling. So we are told that the radius OC is 5, so that means this whole segment here is 5. We are told chord AB is 8. And when it says 8, it's referring to the whole chord. That's 8. Now, I know that the whole chord is 8, but using that first guideline I was talking about earlier, let's go to it. Remember that the bisector will split the chord into 2 equal parts. So if we apply that, if the whole chord is 8, then we know that PB is going to be 4 and AP is also going to be 4. And we're being asked to find the length of OP. So we are supposed to find OP. Well, the other guideline says to draw a radius. So I'm going to go ahead and draw a radius from here to here. And of course, OB is 5 because the radius is 5, right? So OC is equal to OB. Now, the next guideline says to highlight the right triangle. So hopefully you could see that there is indeed a right triangle right over here. And we can use the Pythagorean theorem to find OP. So I'm going to go ahead and label OPX. So the Pythagorean theorem is, of course, a squared plus b squared equals c squared. So we have x squared plus 4 squared equals 5 squared. And hopefully by now you could see that this is going to be a 3, 4, 5 right triangle. So x is, of course, going to be 3. Okay, I hope this video helps. Have a good one.